Hello and welcome to another case walkthrough. Today we're looking at another case from the Brazilian 2024 Championship, slowly working my way through the back catalogue as still feel like a relative newcomer to all of this. So this is a case by Thinsman and Andrew. I'm going to assume if you're watching this, you're someone who's either attempted or about to attempt this case. So another, in some ways, quite simple setup. All of the information, all the questions relate to this map here, which is representative of regions of Brazil, and the arrows represent flow directions of water. So we're meant to imagine that if we were to land on a cell here, for example, we would follow the arrows until we eventually, every single option eventually ends up outside of the map as the water flows. We've got some regions, some absorption rates, some codes, and that's the basic setup. So it is a map case in the traditional sense, which isn't an area I feel particularly strong on. So this will be interesting to see how I do. I've done some of the setup work just to speed up this walkthrough, so we're not wasting anybody's time. So yeah, I think that's all I need to say about this case. We've just over a minute already, so let's get started. So level 1, if a raindrop falls in the cell shown, in which direction will it move? In other words, we're looking at the cell, we want to find the arrow in it. So I'm going to import my lambdas and I'm going to use my address lookup. Actually, I need to define the area. So let's select the map and let's call it MP for map, which seems to be the common usage, and we'll just say address lookup in the map, and we'll point to this, and I think I can give it a range, and I think we should be okay. Yes, so we get all the arrows, all ticks. Let's move on. Level 2, if a raindrop falls on the featured cell, what is the next cell in its path? So I'm going to use a combination here, so I'll work up here just to show my working. So we're going to start off by, we need to find what is in the map itself. So again, address map pointing at the cell. We get a left arrow. So now I'm going to combine that with my move on map lambda, where I'm going to take the starting point is the same cell address. We've now given it the arrow by looking that up, and I don't think I need to give it anything else. I'm assuming that they're all within the bounds of the map, so I don't need to use any of those optional arguments. And yep, that works nice and neatly. What is the code of the region referred to in the cell presented? So the codes come from here. They're represented by color. So we're going to do some color manipulation. So I'm going to copy the map. I'm actually going to copy it into the same region. I've noticed that if I try making a copy, normally I make a copy in a new sheet, but if you've already named a range, then it can start getting confused because you have different versions of the same name, and I'm not really sure how to deal with that. And so to avoid, I'm just doing it here. So I've selected the map. I've got a lambda, not lambda, but a VBA that then inserts the color code. I also need to find the color code for the region. So if I select this area and do the same bit of VBA, we get codes. So we've already named this map. So let's name this something. Let's call this regions. And we're going to start building some flattened data. So I'm going to call the map to get the arrows. I'm going to call the cell address of the map to get the actually no, that's the regions. So call the regions, but that's not correct yet because then I need to XLOOKUP those on. Let's see. I'm trying to use my keyboard as much as possible. So we're looking those up on this column and returning. Nope, not the row. We're returning the column. And we get the region codes, and then this is the call of the cell address of the map. And then we'll do the absorption now, even though it only comes up later. We basically need to XLOOKUP the region in this column and return this column. And that's all our data set up. And then I'll select all of that, Control Shift F3, and we'll name those ranges, and that should put us in a good stead. So now what we're doing is we can now just use an XLOOKUP. So we're going to look up the cell in the map references, returning the map regions. And that should, something's gone wrong there. Have I used a slightly different acronym as before? Let's go to my map. MREF, I've referred to, it's MREF, not MREFs. So There we go. Okay. Level 4, how many steps will it take for a raindrop falling on the cell presented to reach a different region? So I'm going to use a data table for this. So we need to work out where we're starting. Well, we'll just point to cell B1. And then the question is, where are we going to go next? So I'm going to actually grab the workings from level 2, which is here. And if I paste that there, it will say it's got an issue because it's pointing out the wrong place. But we're basically saying, and this annoys me because I have copied the formatting as well, bit OCD there. So we've now, we're now pointing, saying where would the next one be. And if I were to do this down manually, it kind of points to an issue. But actually, I think what I can do, and then we get this weird one where it spills out if there's an issue. But I'm going to actually get rid of that issue by getting rid of this address lookup, which I think is causing the issue. So we're going to move on the map from that cell, and then we're going to actually X lookup E3 in the map ref and return the map arrow. And that seems to resolve that issue where we don't get the spill anymore. And then what I actually want to do, rather than having to do this drag down, I'm going to try and do this dynamically. So I'm going to scan from my initial value over a sequence of, let's say, 15 possible moves, and then my lambda, I'm going to put an input of X and then replace my original references with X, and that should give us an issue, but something has gone wrong. So let me just check what's gone wrong there. Yes, the issue is because I'm using a lambda inside a scan, I need two variables, X, and normally it would be the value, but because I'm just using the sequence to count through, I'm just going to put an underscore, and then there we go. So we get dropping out all of the possible options, and it then tells us when we get outside of the map. So what I'm going to do is I'm now going to VStack all of these together. I'm going to VStack the original cell and then the spilled array. So we've then got one dynamic array, and now we can X lookup in the map ref to return the map region. And then what we want to do, and then we'll say if it's an error, we'll say out of bounds. I'm going to accept that correction. Yep, that looks good to me. And then we need to work out when this changes. So the way I'm going to do that is I'm going to basically, let's think about this. I basically want to just say when this range doesn't equal the first cell, and then we get false, false, and then we get the first trues when it changes. And so that's on the third row, and it's cell D9. So basically what we're going to then do is we're going to X lookup true in this range and return, although it would, oh gosh, that's not dynamic. I don't like that. So let's make that dynamic. Let's VStack that and that, and then return. That's the return range, and we get D9, good. And then we're also going to then join that with a dash, and we're going to X match true in the change range. And then we get D9.3, and let's just point our data table to that. Example is good. Let's go to the case, and they're all green ticks, so we're good to go. Okay, what is the code of the region referred to? Oh, no, sorry, I was looking at the wrong one. That's level 4. There we are. So level 4 is all correct. Okay, level 5, we need to calculate the total amount of water remaining after a few moon moves and consider the absorption of each cell. Again, this for me makes more sense when I look at the example. So going to build it as a data table, which we've already done. This is going to be very similar to the last one. In fact, let's see if we can just copy some of this working over. So we want to start by basically saying where are we going, and getting all the cells. This time we're limiting this based on the number of movements, so we're only going 4 movements. So what I want to do is I'm going to change the sequence. Instead of 15, we're going to say that -1, because obviously the first step is considered the first movement. We're no longer dealing with whether it's changed or not, so we're now also no longer looking at the region. Are we looking at the region? What is it the question is actually asking for? We're looking for their absorption. Oh yes, we need the region because their absorption rates are based on the region. So we can then X lookup the this on M region returning, oh no, we haven't actually done the absorption yet, have we? So let's do that now. So we go to our data. Oh no, we have done an abso, we've got it over there. So X lookup the, actually we only need this second set of cells because it says we don't use the first one. So if I go X lookup these in the mref and return the absorption rate, so we get 0333, which is what we get because we ignore that first one. And then what we can do is we can actually scan through that. So our initial value is going to be 15, which is what we get in the question. Our array is going to be this, and we're going to take the product, but this isn't going to be correct because it's actually, the absorption rate is how much is taken away, and we need to multiply what is actually left, so it's 1 minus that. And we see we get the expected answer here, so I'm just actually going to change this to a reduce instead of a scan, and then the answer is that, but we round up, and this caught me out the first time I did it because I just saw the word round and I didn't round up to 2 decimal places, and so half my answers are wrong, and I could not for the life of me work out why. Okay, that's level 5. How are we doing for time? 11 minutes minus the minute at the start, so 10 minutes so far. Level 6. This I'm going to actually not use a data table, and this was an opportunity to test my understanding of regex because we're given cell references but with no delimiters. And actually, once we've split those up, this is, I think, an easier question than level 5 I found. So I'm going to regex extract from here, and my pattern, every cell reference has at least one letter and at least one number. So I'm going to say I want a non-digit, so a capital D plus, we need at least one, and then a normal digit plus because we need at least one. And if I put return mode 1, we're going to get all of those. And I might just, to make this easier to see, make that 2 cols. So we've got all of our cell references, and then we need to find, so let's build this into a bit of a let. So those are our cells. And then we want to expand the formula bar. So we want to grab their absorption. So let's call A or X lookup C in the map refs and return the map absorption, which gives us those numbers. And then we're going to multiply those by extracting the numbers from C. Oh, it doesn't like that because it turns it into a condition, and we get the numbers we're expecting, and then let's just sum that all together and we get 13.83, which if we fill that down and then reference that, we get green ticks all the way, which is good. Right, level 7. I'm going to take, this is by far going to be the longest, and the approach I took, I've watched Dim's walkthrough or testing of this case, and he did a very good solution, as you'd expect, where it worked out that we go through the map. Actually, kind of the workings from level 4 sort of could help us here, because we find out if this is our starting point, where do we end up going? And then you can kind of reverse engineer, because if you create that as a string and attach it to each one and then look for the strings where a certain cell appears, that's the number of times it goes. Now, that wasn't my approach when I first tried this, and I'm going to try and replicate what I tried before, which is a kind of, I guess in some ways, a programming response where we start at each cell, work out which ones point into it, then work out the next layer, then the next layer, and keep adding it on, which, yeah, it's going to hopefully make more sense when I actually do it. So if we start by pointing to the cell where the answer is, and I'm going to change this back to example 7. So I want to start by finding all the neighbors, so the 8 cells around it. So I've got a neighbors lambda, so I'm going to point at that, and I want to use including the diagonal, so option 2. For the moment, I'm going to include the arrows, and I'm also going to include the map, but I am going to keep those coming through. So we see for R3, the cells around it are R4, R2, so on. These go up, down, left, right, and then the diagonals. And what I want to do is I also want to see what the arrows are in those spaces. So if I say address lookup in the map, these cells, we see which arrows are in there. Okay, and what we want to do is, let me just think about this clearly. So what we're trying to work out is we're saying cell R4 is the one that is below R3. So we want to see whether the thing below it is pointing up into the middle cell. So let me put this another way. So if I've got R3, I'm going to say normally we'd go up, right, right, down, down, left, and up, left. And if I use my arrow from text lambda on that range, so normally our neighbors, we're saying, right, look in each direction to see what they are. But if we were to change those around and say, well, actually, I want the complete opposite. So I'm going to go down, right, down, left, left. That's going to be up, left, up, right, and right. We're now saying, yeah, we want to actually look at anything that is pointing towards the cell in the middle is a viable path. So what I'm going to do is I'm going to delete that, and I'm going to basically replicate that up here. So for R4, we want to include R4 if it is pointing the opposite of this direction. So we're going to go up, down, left, right, up, left, down, right, up, right, and down, left. And then I'm going to go arrow from text on those, and then I'm going to actually change those to static values. Okay, and I'll just get rid of this. And what I want to know basically is whenever these actually no, those are no longer the values I want, so I'm going to get rid of showing the arrows. I now want to find what is in each of these cells, so I'm going to use address lookup in the map, this, and I now want to check whether these values equal these values, and where they do, where they are true, that means that those are cells which pass into that. So if I were to now filter this list based on that list, we see from R3 we can actually get there from S2, S3, S4. Okay, so that's the kind of the workings we're trying to build. So I'm going to now build this into a let that does this, or a lambda that does this on one cell starting point. So let's just get this all into one thing, because at the end I want to have a single cell output. Okay, so if my starting cell is R3, those are the next points. Now I'm going to go to what happens if we have cells that are outside, because it then causes problems here. So this formula, I'm going to add in an if NA and give me a way to basically deal with those errors. So now what I want to do is get all of this into a single cell. So I'm going to start from left to right. I'm going to grab this and put it inside this cell. And then I'm going to grab this. And I could use OA robot here, which would probably speed this up, but I like to do the work here to help me understand exactly what's going on behind, or under the hood rather. And then this is, I think, going to go into here where that is H4. Just need to grab this formula here and put that in here. Okay, so I've now got a single formula, and I'm going to turn it into a lambda where I'm going to have my cell as the input and replace all the references to E4 with my cell. Okay, and that creates my lambda. And it doesn't return anything because I'm not pointing anything, but if I put that back, we get it. If we go back to example 7, great. Okay, so now we've got a lambda that goes from one cell and maps it through to whatever the following cells are, but we now need to be able to get it to iterate multiple times. So what I'm going to do is I'm going to put this into a map, and I'm going to map over an array where I'm going to text split. I'll point this as an example, text split this on the pipe. And then my lambda, I should have copied this first. So let's copy the lambda, which works on a single cell reference, but we don't need the cell reference. So map over the text split, map text split our cell based on a pipe. And our lambda is this, and we'll have to close off the bracket. And then we now we're getting there. So we're now seeing the next iteration of cells, but we're occasionally going to get a calculation error where something goes outside of the bounds. So I'm just going to solve that for now, not in a particularly neat way, by 2-rowing and putting a 3. And then I'm going to text join this with a pipe, ignoring any blanks. And now we've got the next step. And if I were to keep doing that down, we'd see each next step until we get some calculation errors. And I could probably just do that manually by dragging down and doing multiple versions, but I want to turn this into a proper kind of dynamic formula. So I've now got a lambda, which if I change this to a lambda and put input, which is multiple cells rather than a single cell, I've now got a lambda that works on a multiple cell input. If I point it to this cell above, we see that. So now what I should be able to do is turn this into I'll do it as a scan over our initial value, which will be in cell E4. We're going to go over a sequence of 15 times, and because we've got inside a scan, we need to add an iterator, so we're just using underscore. And we should, brilliant, it is working as expected. We now get all of our outputs, and I'll actually delete that, move that up. And I could tidy this up by just going 2 col and 3. And so we've now got all of the possible outputs. And again, this isn't the neatest way of doing it. I'm now just going to text join those with a pipe, which is going to give me all of the possibilities. And for now, I'm going to leave that there because I think I need it later. I'm going to say, right, I want to count how many there would be if I text split this based on a pipe. And we get 7. Let's hope that has worked for the rest of them. We go to the case, level 7. Oh, we've got some mistakes. And that's because if we look at one of those mistakes, so you'll see these are very big numbers, notice, or most of them. So if we go to 122, so go to 122 as an example. Let's try just simply changing the sequence up to 30 and seeing if that solves the problem. So yes, we just didn't do enough iterations to start off with. So there we go. Right, 22 minutes or 21 minus the minute starting, just time to do the bonuses. I always try to get these under half an hour because if you can't explain them in half an hour, how do you expect to solve them in half an hour? Right, if each cell in Rio Grande do Sul has an area of 1374.4, what is the total area of the state? So let's go to this, and I'm going to do, let's do this as count ifs the map equals these here, and it's not the map, it is the regions. Oh, something gone wrong there. Nope, because it's not either of those are actually still the colors, so I need to count if region. Excellent. So the sum of those is 206. So 206 times 1374.4 equals 283,000. What's the absolute difference between the number of cells in Rio Grande Sul and those that aren't? So if I just copy that formula down to here and then sum that, and we've got 206 minus 194, so that's 206 minus 194. Should be able to do that in my head, but anyway. 12. How many cells from the edges of the map have arrows that are pointing outside the map? Given the size of this, I'm just going to eyeball it and count them. So I'm going to select them as I go. So pointing outside that. In fact, most of these, not quite all of them. All of those, not that one. Those. All of those, all of these, not that, none of those, that one. If I just put those in a completely random color, and I've selected 35, so that should be 35. There is a way we could have done that kind of formulaically. We could have got our lambda that tells, or not lambda, but the formula that tells a cell and tells us what's next. Put it over here and count how many of them point to outer bounds. How many times do diagonal arrows appear on the map? So let's just do a group by. So group by map on map. Count all 0, 0. Don't think I actually need those functional. Oops, what's going on there? Group by map. Do I need to? I think I need to call it. I'm trying not to use a lambda here when I could have done. because my lambda, my most least lambda would have dealt with this. Yeah, so what was the question? How many are diagonals? So let's go into this. So diagonals is that, plus that, plus that, plus that, which is 212. And except for the edges of the map, each cell has 8 neighboring cells, 2 vertical, 2 horizontal, 4 diagonal. Which cell has the most neighbors pointing towards it? The answer should be the cell written in relative reference format. So our workings on level 7, this should actually work on a single cell. So if I go to my data and copy that there, it's going to be pointing to the wrong cell. If we point it to the reference, some of them are going to return errors because they don't have anything, but I think if I drag that down, oh no, that's doing the whole thing where it's cycling through all of them. So I want to just get the single version. So how about, I kind of need to grab this in here. So it's this lambda here, which is all of that. So let's grab that to the lambda. Let's go back to the flow. Equals that, but it's pointing at the wrong cell, so, or it's not pointing at any cell, so let's point it at that. Again, some of them will return errors, I believe, because of where they are. Yep, so we're looking for the one that has the most. So let's just do what we did before. So if error will give us a 0, but otherwise what we're going to say is count all, text split the cell on pipe, and I think that's good to go. Oh, is that going to give me error? When there's an error, it's actually going to return a 1. I'm not going to worry about that. We're just going to find the maximum it's saying is 5. I think that is incorrect for some reason. Hold on. No, it's not incorrect. If I find the maximum, which is 5, we get it here because there are 5 cells, and that is on cell D9. Not sure why I didn't trust myself on that one, but that's correct. Okay, time, just over 27 minutes, so minus the minute we chatted at the top, that's 26. So yeah, interesting case. I think level 7, I mean, I don't remember the exact timings, but I think it was kind of 7 or 8 minutes on that. So that's probably a little bit too much for, or I'd have to do the first few levels really, really quickly to have given me enough time. But I'm glad to have done the practice there, because this sort of recursive, is it recursive? Is that term? I don't know. This kind of iterative building out is something that I think I have seen in cases. Certainly none of the live ones I've done since I've started, but certainly old cases I've gone through, that sort of approach is something I've seen. So yeah, really enjoyable case, and always, as always, an opportunity to learn something new and apply something new, and like I said, with that recursive solution on level 7. So thanks very much for watching. See you next time.